Okay guys, today we're going to go over the electrical pathway of the heart. Now again, a disclaimer is I do realize this is not the anatomically correct heart and this is not what our heart looks like, but I use this diagram so that it's easier to understand and then you can apply it to the anatomically correct heart. Okay, 2 words we need to go over real quick. Depolarization means contraction. Okay, so we're no longer going to say like the atrial cells contract, it is that they depolarize. And when these myocardial cells, either the ventricular or the atrial cells, relax, it's called repolarization. So that's easy to remember because you relax, repolarize, relax. So that is what the terms that we will be using. Now, one thing that I do in class, if you were not here today, is that we clasp our hands together, which I'm holding the phone with one, but like you would clap, and then relax when we repolarize. So we can even do depolarization, repolarization, depolarization, repolarization. Okay, so that way it kind of gives us a mental image of what's going on in our heart. Now, we're going to start with the sinoatrial node or the SA node. Now, this is somewhere in the wall of the right atria. You cannot really see this area. I've just made it a dot so that we are able to identify where it would be located at. This is the SA node. Now, this is the pacemaker of the heart, and this is definitely like the boss. So you do need to know that the other name is the pacemaker of the heart. I just call it the boss. It's the one in charge, typically. And it initiates the heartbeat, and its intrinsic rate is 60 to 100 beats per minute. Now, one thing to note is the SA node only talks to the atrial cells. So I always say that the SA node's kind of a little stuck up. It only likes its people. So it only talks to the atrial cells, and it tells the atrial cells to depolarize. So the SA node tells the atrial cells to depolarize, which we know that means contract. So the SA node initiates the heartbeat by saying depolarize, and the atrial cells all depolarize at one time to give that effective pump. Because remember, the electrical pathway also interacts with the pump of the heart. So when it tells the atrial cells to depolarize, all the atrial cells at one time depolarize to give that good squeeze to kick the blood from the atriums down into the ventricles. Okay, so that's really what's happening. So we have an electrical pathway basically in our heart. So that impulse goes from the SA node to the atrioventricular node or AV node. Y'all, this sits in the center of the heart. Now, really, it's atrioventricular because it talks to the atria and the ventricle. Okay, it is the second in command. So it's like the assistant boss, but it is known as the secondary pacemaker. Okay, that's what it's known as. So the SA node's the pacemaker, the atrioventricular node is the secondary pacemaker. Now, this talks to both the atria and the ventricle. So the SA node's a little stuck up. The AV node talks to everybody, likes everybody. Now, its intrinsic rate, if it is in charge, is 40 to 60 beats per minute. So what happens is the SA node, this is what happens. The SA node only talks to the atrial cells. So when it initiates the heartbeat, because it is the pacemaker of the heart, it's going to tell the atrial cells depolarize, and they all depolarize at one time. Okay, so the atrial cells are depolarized. Well, the SA node sends that impulse on to the atrioventricular node. When the atrioventricular node gets that impulse, it talks to the atrial cells and it says repolarize to the atrial cells. So the atrial cells now relax, and it sends an impulse now down the highway, and it's trying to tell the ventricles, well, it is telling the ventricles to depolarize. So we've got the atria relaxed, and now we send the impulse along telling the ventricles to depolarize. Now, the bundle of His, it literally only talks to the ventricles, and it regulates the heartbeat. So the bundle of His has a very important role where it just kind of holds that impulse for a minute while we're letting the atrial cells fully repolarize. Okay, so it holds on to this, and then it kicks it to the Purkinje fibers. Now, the Purkinje fibers are these little finger-like things that are all in the ventricle cells. So they're innervating each ventricular cell. And once the bundle of His, we know it regulates the heartbeat. You need to know that. Bundle of His regulates the heartbeat. It holds on to that impulse for just a minute, and then it sends it to the Purkinje fibers. And the Purkinje fibers then tell the ventricles, depolarize, but they're kind of all throughout the ventricular cells. And so when it gets that impulse from the bundle of His, which came from the AV node, now the Purkinje fibers say, depolarize, and all the ventricular cells depolarize at one time. And we know the atrial cells that are already relaxed. And so the bundle of His, like I said, just regulates it, lets this one relax before this one depolarizes. Now, when the ventricular cells depolarize, they squeeze, the right side of the heart squeeze all the blood out into the lungs to get oxygen, and the left side of the heart squeezes all the blood out through the aorta, we know, to go to the rest of the body and oxygenate them. Now, that is in a perfectly working heart. And all of that happens 60 to 100 times a minute in coordination with the pump, if the SA node is in charge, okay? So that is the normal electrical pathway through the heart.